Hey, pre-calculus. This is the notes for section 5.2, all about verifying trig identities. Verifying trig identities. So a couple of things that might help you out right now before you get started is not only make sure you have a place that you can take your notes, you can follow along, you're in a good frame of mind right now to take those notes, but also you might want to have out handy your trig identity sheet, that formula trig identity sheet that you got in class, hopefully. That might really be handy, might really be helpful as we go through and try to solve some of these. So if you want to take a moment here, pause and get yourself squared away with all that stuff, might be a really good idea. All right. So to verify these trig identities, essentially, this is very similar to what we've been working on over the past couple of days. Very similar to that. Couple little things that might make this easier, a couple things that might make it a little trickier. All right. So first up, to verify that a trig identity is valid, is true, you must show that both sides simplify to the same expression. So you got to somehow get both sides of that equation. Both sides ended up equaling the same thing. You have to show that somehow. There's a whole lot of ways to go about doing this, a whole lot of ways. A couple general strategies. General strategies, number one, the proof. And be careful when you say proof, because not like proofs like geometry, it's kind of just making sure you go through algebraically and trigonometrically that it's true. The proof begins with the expression on one side of the identity. You have to start somewhere. So you start with one side of the identity. All right, you either start with the left side or you start with the right side. The proof ends on the other side. So essentially, you know you're done when you start on one side and you end on the other, or you start at the final side and you end at the beginning. So it doesn't really matter which side you connect to the other, but you have to connect them somehow. And the proof in between consists of showing a sequence of expressions. All right, a sequence of expressions, each one easily seen to be equivalent to the one before. So you have to make sure you can't just say, oh, I did all this work and the answer is 4 because it is. That's not easy. You got to make sure it's easily expressed. All right, general strategies, part 2. Begin with the more complicated expression and work towards the less complicated expression. That's a strategy. It might help you out. Start with the thing that's more complex and make it look a little bit easier. All right, general strategy number 2 there. If no other move suggests itself, convert everything to sines and cosines. I know we talked about that strategy before in the past, but if you can't see any of the other identities out there, you can always use sines and cosines to kind of work with that one. And then general strategy number 3, combine by combining them over a common denominator. If you have fractions, you can combine them with a common denominator. Always work on doing that too. All right, general strategies, part 3. Use the algebraic identity, a plus b times a minus b equals a squared minus b squared, to set up applications of the Pythagorean identities. So use that idea of dots or that idea of the conjugate to start working with the Pythagorean identities. That's something that might help you get moving. And then always be mindful of the target expression. You might not know how to get there, but you know where to go. And if that's the case, you might be able to kind of manipulate your way and finagle a way in there. All right, to make sure you get closer and closer to your goal. So always be mindful of that target. All right, so let's see what we're talking about here. What exactly is this verify expressions type of thing? So a little example right here, verify each. I've got the secant times the cosecant is equal to the cotangent plus the tangent. So in the past, what happened was I only gave you that right there. I only gave you secant times cosecant, and I said simplify it as far as you can. Now I'm telling you what it does simplify to. It simplifies to cotangent plus tangent. Okay, so that's what we're going to try to get to. So start on the more complicated side. I don't really see one being more complicated than the other, so maybe I'll start on this side. I'll start over here, and I'll try to get over there. That's my goal. My goal is going to be cotangent plus tangent. All right, so if I have secant times cosecant, maybe I can Maybe I can turn them into sines and cosines. See what happens there. Maybe it's 1 over cosine theta times 1 over sine theta. Okay, all right. So from here, I don't know, I multiply straight across, so that's going to be 1 over cosine theta times sine theta. Huh. Okay, all right, all right. Now I know I need two things. I need to add two things together because that's what my goal says, add two things together. And one thing that I notice here is this 1. And that 1 I could use as the Pythagorean identity. I could say that's really going to be a sine squared plus cosine squared is equal to 1. So what I could do is I could say that's equal to a sine squared plus cosine squared. All right, and it's still divided by cosine theta times sine theta. Okay, well now I have two things that are added. I can split this up into two fractions. I can say the first fraction would be a sine squared theta over cosine theta times sine theta. And then the other fraction would be a cosine squared theta over the exact same denominator, cosine theta times sine theta. All right, let's simplify these fractions. Let's see what happens. Well, the squared on the top goes away and the sine on the bottom goes away. And then the squared on the top goes away and the cosine goes away. So if I simplified it down, I end up with a sine theta over cosine theta plus a cosine theta over a sine theta. All right, and using my identity sheet, I know that sine over cosine is going to equal a tangent. And a cosine over a sine is equal to a cotangent. If I'm looking to see what I'm trying to get to, I'm looking to try to get to cotangent plus tangent, which is what I have. Cotangent plus tangent is tangent plus cotangent. So I've got it all simplified out. All right. So some of the steps are very, very similar to what we've been working with. Some of them might take a little bit more, like trying to realize how to transform that 1 right there into sines and cosines. All right. So we'll keep practicing, and let's try another one here. Let's try 1 over 1 minus cosine times 1 over 1 plus cosine has to all equal cosecant squared. All right, again, start on the more complex side. So this is maybe where we want to start. This definitely looks a little bit more complex, and this would be the goal. The goal is cosecant squared. All right, so 1 over 1 minus cosine, 1 over 1 plus cosine. And it's multiplied. It's multiplied. So I don't have to have a common denominator. I can just multiply tops together, bottoms together. 1 times 1 is 1. Boom. On the bottom, 1 minus cosine times 1 plus cosine. All right. Well, I could go through and I could FOIL that and see what happens. So I'd have 1 on the top. 1 times 1 is 1. 1 times cosine is cosine. Negative cosine times 1 is negative cosine. And negative cosine times positive cosine, negative cosine squared. All right, okay. Let's see here. Maybe from here, I got like terms. I can combine some things. I've got cosine minus cosine. They cancel out. So I'll end up with a 1 over 1 minus cosine squared. Hey. 1 minus cosine squared. Isn't that the Pythagorean identity? So wouldn't that be 1 over sine squared? Oh, and if it's 1 over sine squared, that's like 1 over sine, so that's going to actually be the reciprocal identity, cosecant squared. Wait, that's what I wanted to try to get. That was my goal. So I'm in good shape. I've got it all set to go, and I can clearly see all the steps rather easily. All right, let's try a couple more.